Hello and good evening, everyone. I welcome you all to India's largest e-learning platform, Unacademy, and I welcome you all to Gate Conqueror channel, and I welcome you all to my session of Antennas MCQ series. Sorry, dear. Sorry. Just confirm the video and audio once. Welcome you all to the Antennas MCQ series, part 2. This will be useful for GATE, engineering services and all other competitive exams, including HAL and BARC. Elango, good evening, dear. Before we start the class, let me introduce myself. I am GC Reddy, having overall experience of 15 years in teaching, guiding and mentoring GATE and ESC aspirants. Worked as motivation speaker pan-India from the past 12 years, an expert in field theory and communications. This is an official Telegram channel for the GATE Conqueror channel. And the good news for all the GATE Conqueror followers is within couple of days, new educators are going to join us. We are strengthening from hand to hand, and new educators are going to join us. Just a second here. Yeah. And definitely we have the strength to cover all the subjects of GATE 2023 comprehensively on the first hand. So that's the good news for you people, that we can cover comprehensively now GATE 2023 without any doubt. And this is the official Telegram channel for the GATE Conqueror channel, and this is the link. Take a screenshot of it, and after the class you can join us on Telegram. Remember, dear, coming to EMF subject, most comprehensively we will be able to cover EMF on our channel. I will give a review of what we have done before we go for MCQ. This particular series is intended for practice for GATE, ESC and other competitive exams. What we have done in EMFT series, I'll explain once. Then we'll go for the MCQ series, part 2. And remember, dear, in the morning session we had completed 20 questions. We'll be continuing from that particular part. Almost I'm trying to plan to cover around 500 questions on antennas. So that is what we are planning, dear. With this one series would be enough for you to comprehensively understand the concepts. Any doubts, please let me please ask, dear. Good evening, Elango. So we are into the Antennas Mahamarathon series. Of course, we've done an Antennas Mahamarathon series, and now we are going for MCQ. Now let me explain what are the playlists that we have on our channel. We have a playlist with 40 videos, and 50 hours of recording. We have a playlist with 40 videos and 50 hours of recording on EMFT Module 1, Electromagnetic Field Theory. Module 1, which is Elements of EMF Theory. We covered complete syllabi, theory, derivations of this particular concept that will be useful for electrical people. Covers the complete syllabus for GATE and engineering services. These videos will be useful for any other competitive exam where EMFT syllabus. For Triple E, this playlist is exactly suited. And for EC people, this is one module, that's it. Out of 5 modules that we have in EMFT, this is one of the module which will be covering both GATE and ESC and other competitive exams also. So this playlist is already available where we have completed module 1. Then there is a current series going on module 2, EMFT module 2. EMFT module 2, EM wave propagation. Generally for elements of EMF theory, you go for any YouTube platform. On the YouTube platform, you go for any channel, you will get max content of 10 hours. Max to max, you will get content of 10 hours. But we got 50 hours of content here only on elements of EMF theory. And in EM wave propagation, already we have recorded 8 videos spanning around 18 hours. It covered EM wave propagation, in free space, materials, good conductors, good dielectrics, and perfect dielectrics. Along with that, theory of pointing theorem is also done. We need to do numerics on pointing theorem, wave polarization theory and numerics, and reflection, refraction of plane waves theory and numerics are left out. That will be covered in EM wave propagation 9, 10 and 11. That will be continued in this week. So within 7 or 8 days, we'll complete module 2. That too, around 25 hours of recording we'll do for module 2. 25 hours of content will be available. You can see already 75 hours of content is done only under these 2 modules. And also, very soon I'll start module 3, transmission lines, and module 4, wave guides. I'm planning to start this in March parallelly. I'll start them parallelly. And anyways, for module 5, that is antennas, you have 2 concepts: antennas and optical fiber communication. Optical fiber communication, I'll start separate series next week. This will start in the next week. On antennas, we had covered antennas Mahamarathon series. Exclusively, we had covered antennas for GATE and ESC. This is also very unique series. Just like EMFT Module 1 series, this is also very unique series where we had covered around, we took around 18 videos and we had covered around 35 hours of lecture only on antennas. In antennas also, dear, max to max on any YouTube platform, you will find 5 to 8 hours of content. Already 35 hours of content is done, and I am planning to cover some more previous year questions and 100 to 200 practice questions in Antennas Mahamarathon part 19 and 20. That also I will complete very soon. So why I am telling all this is on our Gate Conqueror channel, we are having all this related to EMFT. You need not go anywhere, dear. Everything is here. Besides this, now we are into the antennas MCQ series also. That will be useful for all the other competitive exams. Is that clear? So within a week, I'll complete this module 2, just like we completed module 1. We'll complete module 2 and module 5 very soon. Almost now, near about 110 hours of content is already available only on EMFT in these modules. So near about, like generally you see people teaching 50 hours of content for EMFT. For us it will be like 200 hours of content. 200 hours of content will be there for EMFT. So that is what I am trying to plan. Everything will be there in that EMFT. Okay. Is that clear? In the previous session, MCQ series part 1, MCQ on antennas, part 1, we had covered around 20 questions plus theory related to antennas. In this particular session, we'll continue from question number 21. Now, if power in main lobe, if power in main lobe is 100 watt, side lobe ratio SLR is minus 20 dB, then side lobe power is dash watt. Do it here. Everyone do it. The power in main lobe is 100 watt. Side lobe ratio, also called as side lobe level, is minus 20 dB. Is asking find the side lobe power. Side lobe power is dash watt. Okay. Now if you see, power in main lobe is 100 watt. Side lobe ratio or side lobe level is minus 20 dB. Then what would be side lobe power? Minus 20 dB means what will be power, dear? Anyone try to solve? Minus 20 dB means how much will be the power? Minus 20 dB means how much will be the power? Power here, I'll explain, listen carefully. For example, power is 10 watt. Convert it into decibel. Power in decibel. 10 log 10 to base 10. It is 10 decibel. If the power is 20 watt, power in decibel, 10 log of 20 to base 10, it is 13 dB. If power is 40 watt, power in decibel, 10 log 40 to base 10 is 16 dB. Power is 80 watt. Ten log 80 to base 10. Please check everyone. Everyone please check. It is 19 dB. And when power is 100 watt, power in decibel, 10 log 100 to base 10. 100 is 10 square. So that is log m power n log m. So you got 20 log 10 to base 10, 20 dB. Power is 160 watt. Power in decibel, 10 log 160 to base 10, 22 dB. Power is 320 watt. It is 25 dB. $640 watt. Ten log 640 to base 10, 28 dB. 1000 watt. Ten log 1000 to base 10, it is 30 dB. Why I am explaining this? Because now if you see the analysis, when the power is 10 watt, the value of power in decibel is 10 dB. When the power is 20 watt, the power in decibel is 13 dB. That means when the power got multiplied by 2, increase in decibel was plus 3 dB. In the reverse way, the power divided by 2, the decrease in decibel is minus 3 dB. This is called as 3 dB rule. By 3 dB rule, for every plus 3 dB, the power will get doubled. For every minus 3 dB, the power will become half. Any doubt? Clear? That is 3 dB rule. This pattern continued. Power got multiplied by 2. We got plus 3 dB. Power got multiplied by 2. We got plus 3 dB. Power got multiplied by 2. Got, sorry. Fine. Up to this point, power got multiplied by 2, we got plus 3 dB. Now the jump here, power got multiplied by 2, plus 3 dB. That continues. Power got multiplied by 2, plus 3 dB. Power got multiplied by 2, plus 3 dB. On the other side, power got divided by 2, minus 3 dB. Power got divided by 2, minus 3 dB. Not here. Power got divided by 2, minus 3 dB. The power got divided by 2, minus 3 dB. Power got divided by 2, minus 3 dB. Basically, that was the rule I explained, which is 3 dB rule. But if you see here, from this point, the power is 10 watt to this point, power is 100 watt. The power got multiplied by 10. How much improvement? Plus 10 dB. You'll get plus 10 dB improvement in power. The power gets multiplied by 10. The other way, minus 10 dB, the power get divided by 10. Similarly, standard rule. Now if you see here power is 10 watt, here it is 1000 watt. Power got multiplied by 100. Improvement in dB, plus 20 dB. Plus 20 dB, its power get multiplied by 100. Minus 20 dB, power get divided by 100. Similarly, it goes on. Plus 30 dB, the power get multiplied by 1000. Minus 30 dB, the power get divided by 1000. So that's the rule here. Now for voltages, the same concept. For at the place of 3 dB, you'll get plus 6 dB. And minus 6 dB, we'll discuss that about this on any other day. This is for voltages. Clear? Now, if you see the question, learning concept will take time, dear. But once you learn the concept, question will become simple. At least now you tell me what's the answer. Just let me know what's the answer. Now if you see this question, the side lobe ratio is minus 20 dB. Minus 20 dB means divided by 100. Just now I told you the concept. Minus 20 dB means divided by 100. So you need not do anything now. Directly. Plus 3 dB means multiply by 2. Minus 3 dB means divide by 2. Plus 10 dB multiply by 10. Minus 10 dB divide by 10. Plus 20 dB multiply by 100. Minus 20 dB divide by 100. Plus 30 dB multiply by 1000. Minus 30 dB divide by 1000. It goes on. Now this is the concept. Once you know this concept, the moment you see minus 20 dB directly by 100, previously the main loop power is 100 watt, minus 20 dB by 100. So what is the resultant power? 1 watt. How much time it took for you to do this question? Less than 5 seconds. Less than 5 seconds. That is why concept is very, very important. So what's the answer here? Option B is the answer. Learning concept may take 10-15 minutes or 20 minutes or half an hour or 1 hour. But once you learn the concept, then it becomes very, very simple for you people. Got it? Next question. Identify the true statements. Read the question and identify the true statements. Identify true statements. Directivity of half-wave dipole is 1.64. Directivity of half-wave dipole is 2.15 decibel. Directivity of quarter wave monopole is 3.28. Directivity of quarter wave monopole is 5.15 decibel. Identify the true statements. Identify and tell me the answer here. First, read the question carefully. Identify the true statements and let me know the answer. Watch the question carefully, dear. Directivity is a normal value and it is in decibel. It is a normal value and it is in decibel. So try to do the conversion. Try to do the conversion. How do you convert? Directivity in decibel. 10 log of directivity to base 10. That's the hint here. Yes, do it. What's the answer? Directivity of half wave dipole. Directivity of half wave dipole standard 1.64. Find directivity in decibel. 10 log of 1.64 to base 10. 2.15 decibel. Statement 1 correct. Statement 2 is also correct. Directivity of quarter wave monopole is twice of half wave dipole. 3.28. Directivity in decibel. 10 log to base 10, 3.28. Which is 5.15 decibel. This is true. This is also true. All the options are true. Question number 22. Option D is the answer. Now I got a small doubt here. If you do not have a calci, can you find the second term? Anyone? Can you find the second term without calci? We know that directivity of half wave dipole is 1.64 and in decibel its value is 2.15 dB. Now you can use the 3 dB rule. When the value gets doubled, multiplied by 2, 1.64 into 2, 3.28, you will have plus 3 dB. Without any calculation, directly you can tell that the directivity of quarter wave monopole in decibel is 5.15 decibel. Got the logic? You must be able to apply the logic in this way. Is that clear? Let's try to find this. An antenna is largest dimension of 2 meter, operating at 300 megahertz. Then a point on a sphere of radius dash meter will be in the far field region. Will be in the far field region. Try to find out. Try and find out this. An antenna has largest dimension of 2 meter, operating at 300 megahertz. Then a point on a sphere of radius dash meter will be in far field region. Yes, dear. Find out. What is given? An antenna has largest dimension, capital D, 2 meter, operating at frequency 300 megahertz. Then a point on a sphere of radius dash meter will be in the far field region. Then a point on a sphere, then a point on a sphere of of radius dash meter, then a point on a sphere of radius dash meter. This point will be in the far field region. Find out. Hello Satyami, how are you? Find this dear. An antenna has largest dimension of 2 meter, operating at 300 megahertz. Then a point on a sphere of radius dash meter will be in the far field region. If you consider an antenna with the largest dimension capital D, then the region with radius R1 is said to be reactive near field region, and one more with radius R2 is said to be in radiating near field region, are also called as Fresnel region, above which you call it as far field region. Also called as Fraunhofer region. I am doing good, Satyami. Also called as Fraunhofer region. Now you read the question. An antenna has largest dimension of 2 meter, operating at 300 megahertz. Then a point on a sphere of radius dash meter will be in the far field region. Sphere with radius R1 is reactive near field region. Sphere with radius R2 is radiating near field region or Fresnel region. Above that, it is Fraunhofer region. Here R1 is 0.62 into under root of d cube by lambda. R2, which is determining Fresnel region, is 2d square by lambda. If you want Fraunhofer region, it must be greater than R2. That means it must be greater than 2d square by lambda. That's the logic. Now you tell me the answer. The sphere with radius 2d square by lambda is forming Fresnel region. If you want the point to be in the Fraunhofer region or the far field region, its radius must be greater than R2. That means it must be greater than 2d square by lambda. That will give you the answer. Find out. It must be greater than R2, okay? If you want to be in Fraunhofer region, then the point must be at a radius greater than R2. R must be greater than R2. R must be greater than 2d square by lambda. Then you will be in the far field region or the Fraunhofer region. F is given as 300 megahertz. F is C by lambda. Lambda is C by F. 3 into 10 power 8 by 300 into 10 power 6. This is 3 into 10 power 8 by 3 into 10 power 8. Lambda is 1 meter. Substituting R must be greater than R2. 2d square, that is 2 square 4 by lambda 1 meter. R must be greater than 8 meter. 3, no. 5, no. 7, no. Therefore, option D must be your answer. Very important model. This is a very important model, dear. Is that clear? Okay. Shall we go with the next question? An antenna has symmetric pattern in both E and H planes. Symmetric pattern in both E and H plane means in either of the plane the dimensions are same. With half power beam width in E plane is 40 degrees. The number of antennas required to cover a sphere is number of antennas required to cover a sphere is tell me, dear. An antenna has symmetric pattern in both E and H planes with half power beam width in E plane as 40 degrees. The number of antennas required to cover a sphere is. Read the question carefully and answer. This is something related to directivity. Fraunhofer is important. Yes. Importance of Fraunhofer is it is a far field region. All the radiation parameters of the antenna. Satyami, listen. All the radiation parameters of the antenna are measured in the Fraunhofer region. Because in Fraunhofer region you will get stable answers, stable values. Is that clear about Fraunhofer region? Satyami, is that clear about Fraunhofer region? Fraunhofer region is where? Fraunhofer region or a far field region is where we calculate all the radiation parameters of the antenna, because in this region we get stable values. Now, what is saying is an antenna has a symmetric pattern in both E and H planes. Half power beam width, measure of plane angle in E plane is 40 degrees. Symmetric H plane is also 40 degrees. The number of antennas required to cover a sphere Now, by definition, directivity is defined as the capability of an antenna to radiate in any given direction, or it can be defined as number of antennas required to cover a sphere. number of antennas required to cover a sphere. Directivity is defined as, most of the people know the first definition. Directivity is defined as the capability of an antenna to radiate in any given direction. The capability of an antenna to radiate in any given direction is given by directivity. The one more definition for directivity is, it is the number of antennas required to cover a sphere. Now you know directivity is defined as maximum radiation intensity to average radiation intensity. In terms of beam area, it is 4 pi by omega A. Omega A is the beam area. Now, what is the formula for beam area? Thank you, Satyami. What is the formula for beam area? What is the formula for beam area? Beam area, omega A is defined as half power beam width in E plane, half power beam width in H plane, given in steradian or radian square or square degrees, degree into degree, square degree. Because beam area represents the area through which, or beam solid angle through which total power is radiated. Theta E represents half power beam width. The beam width through which half of the power is radiated. Plus this also represents beam width through which half of the power is radiated. 1 by 2 plus 1 by 2. Total power 1. This is in terms of power. But in terms of beam area, this fellow is solid angle. These are plane angles. So when you multiply two plane angles, you get solid angle. In simple, when you have the radiation pattern of the antenna, half power should be considered in the E plane, half must be covered in the H plane. Or this angle and this angle, half power beam width in this E plane and into half power beam width in H plane must be multiplied. Plane angle into plane angle will become solid angle. Will give you the beam area through which the power is radiated. Is that clear? Yes, theta E into theta H. The power concept, is it clear, Satyami? So this is 4 pi by omega A. Theta E in degrees into theta H in degrees. Degrees into degrees will become square degrees. So try to write 4 pi steradian in square degrees. In morning class I explained you 4 pi steradian, how much it is? 41,253 square degrees. How it is, if you want, I'll explain again. If you are having doubt, please ask me. Or else we'll continue. 4 pi steradian is 41,253 square degrees by theta E in degrees into theta H in degrees. 40 into 40, 1600 square degrees. Yes, Satyami, the message going late. Okay, no problem. 4 pi steradian, how it is 41,253 square degrees. Do you have clarity or shall I explain? Now tell me the answer. Tell me the answer. Answer. So what is the answer? (41,253 square degrees by 1,600 square degrees). What will be the answer? Okay, that is 25.78. Very good, Satyami. 25.78. I too got the same one. 25.78. But what is the answer? 25.78. This is 25.78. So out of these four, what is the answer? Out of these four, what is the answer? B. Why? Can you tell me why, dear? Why B? Why B and why not C? Why B and why not C? Why B and why not C? Can you tell me why it is B and why not C? Think and tell me, Satyami. Is it B or C? I doubt. C, taking approximations. Okay, fine. We'll do one thing. Let me consider theta is 39 degrees. Theta H is 39 degrees. Now you calculate theta is 49 degrees, 39 degrees. Theta H is 39 degrees. Yes, I got the answer. How many are attending live is not important really. Because later on people will watch, Lokesh. Anyways, thank you. There was small discontinuity in our classes, so the crowd went down. Definitely it will come up again because so many educators are added now. So many educators are added now into the GATE Conqueror team. We are coming with full force to complete GATE 2023. This is just a sample trailer. People are coming up with wonderful courses. At the start of this class, I also explained in which way we are completing EMFT and communications on our GATE Conqueror channel. So now, yes, I got a point to explain actually. Satyami, can you tell me how much answer you got actually? How much answer you got? With 39 degrees, how much answer you got? Thank you, Lokesh. With 37 degrees, how much directivity you got? 27.12. Now, if you go for your approximation theory, then you'll go for 27, closest value. Here approximation, if you go, you'll go for 26. But let me tell you one thing, dear, listen carefully, very important. Now, how to understand this question is, listen carefully. Yes, Satyami. How to understand this question is, I will explain. Wait. Well, yeah, I'll explain, wait. Now, in this case, 25.78, because 25.78 is very close to 26, the answer is not 26 for this case, because of that reason. And 27.12 close to 27, so answer is 27. That's not the logic, which is wrong. Now, what is correct then? What is correct is directivity. Directivity is defined as number of antennas required to cover a sphere. In this case, when theta E and theta H are 40 degrees, directivity you got it as 25.78. That means directivity is defined as number of antennas required to cover a sphere. 25 full antennas and 78% of one antenna is required to cover a sphere. That's the meaning. So now you tell me how many antennas are required. Is it possible to install 78% of an antenna? Is it possible to install 78% of an antenna? Not possible. Am I right? That means what? How many antennas you will install? How many antennas you will employ? It is not possible to take 25 full antennas and 78% of an antenna. If you take only 25 full antennas, some part of the sphere will not be covered. If we take only full antennas, directivity is defined as number of antennas required to cover a sphere. If I take 25 full antennas, some part of the sphere will not be covered. One antenna, two antennas, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 25. Some small part is not covered, which needs one more antenna. Because by definition, directivity is number of antennas required to cover a sphere. So how many antennas you need to employ to cover the sphere? You can see here how many antennas are required to cover a sphere. If I employ only 25, some part of the sphere is left out. Did you got the logic, Satyami? If I take 25 antennas, a small part will not be covered. What is asking the question? The number of antennas required to cover a sphere. If you employ 25, a small part won't be covered. So how many we need to employ? It is correct. When I said it is wrong then. When I said it is wrong, but the logic is wrong, I'll tell you why. The answer is not wrong. The logic you explained is wrong. Let me explain. Then 25 plus 1, total 26 antennas are required to cover a sphere. Now Satyami, tell me in this case how many antennas are required? Because you told answer 26 by approximation. That's the reason I took one more example for giving clarity for you. Because you told that answer is by approximation. Because you use the word approximation, I took all the pain and explained one more example. Yes, correct. Correct. Got the logic? So you should not do approximation actually. 27.12 may be very close to 27. But how many antennas are required? 28. 27 full antennas plus 12% of one antenna, not possible. So 28 antennas you will employ. Got it? No problem. I can take pain. If you understand this topic, if you or someone, if they can score 1 mark because of this logic, and that mark, if it brings difference in the result from not qualifying to qualifying, some days after 5 years, after 6 years, after 1 year, after 1 month, 1 people, 2 people, 10 people, if their life will change because of our pain, then pain is okay. Okay? So that's the logic, dear. Now, next question. Next question. Amit, are you not following wave propagation? We have completed pointing theorem. Tomorrow there is a class. Tomorrow there is a class, dear, on wave propagation. After completing wave propagation, transmission lines, Amit. Lokesh. Really, that is what we do, am I right? That is what we actually do. We teach so many people only with the hope that everyone will get an opportunity. Everyone's life must change because of our contribution. Option B, why? No. This is MCQ series. This is MCQ series. Which topic you want theory, dear? Tell me. Amit, which topic you want theory? Name of the topic. Module 1 theory is there, no? So much of theory is there. 50 hours of content is there. Module 2 is complete theory only. Around 18 hours we explained, hardly 3 or 4 hours is numerics. Rest of them is theory. Antennas, Mahamarathon, maximum theory, derivations and all. This is series intended for BARC, HL and other competitive exams. That's why question and answer. But remember, this is not just question and answer. I never teach simple question and answer. I always teach question, explanation plus answer. 100%. Those are all the next things which are in queue. Wave propagation already started. Wave propagation, you go through the series. 8 videos are already recorded, Amit. Some wonderful theory is there. Just try to find some time and go through it, okay? Anyways, what's the answer? An antenna has a beam area of 2 pi steradian. An antenna has a beam area of 2 pi steradian. The directivity of antenna is, how it is 3.14, Satyami? Directivity is defined as 4 pi by omega A. Omega A is the beam area. 4 pi, antenna is having a beam area of 2 pi. So tell me how much is directivity now? 2. Option A is the answer. That means how many antennas are required to cover a sphere? Wave propagation theories and whole. Wave propagation Poynting theorem is completed. Wave polarization is left out, and reflection and refraction of plane waves is left out. In this week we'll complete. Communications, don't worry. N. Rao sir have not been for a long time. He will be there next week. Wave propagation, yes, I told you. Now can you tell me why isotropic antenna is having directivity 1? Why isotropic antenna is having directivity 1? Anyone? Can you tell me why directivity of isotropic antenna is 1? Very good. Very good. What is the radiation pattern? Isotropic antenna, what is the radiation pattern? Isotropic antenna, radiation pattern is sphere. In a sphere we have how many steradians? 4 pi steradian. In a sphere we have how many steradian? 4 pi steradian. Isotropic antenna, radiation pattern is sphere. And in sphere how many steradian you have? You have 4 pi steradian. If someone don't know why 4 pi steradian, let me know. Otherwise I'll move ahead. For isotropic antenna, an isotropic antenna is an imaginary antenna or a mathematical antenna which can radiate equally in all directions. Its radiation pattern is sphere. In a sphere we have 4 pi steradian. Substituting directivity of isotropic antenna 4 pi by omega A beam area or beam solid angle 4 pi steradian D is 1 implies one antenna is enough to cover a sphere. Why sphere has 4 pi steradian? I hope you have clarity. If you have clarity, just type clear. Just type clear. If you have clarity why sphere has 4 pi steradian, just type clear. We can move forward. Or else I'll explain, not a big deal. Okay. Actually, I'm sorry to ask. What is your name, dear? Because it displays like Ministry of Railways. Your name, can I know your name? Oh, sorry, really sorry. Because you told me your name once, but I forgot. Okay, with aging, I'm forgetting. We are always with you. We are always with you, dear Lokesh. Don't worry, we are always with you. Now, Satyami, please don't mind. Let me explain, Rahul, why 4 pi steradian. 2 minutes, okay? Is that okay, Satyami? 2 minutes. See, dear, you need to know some small concept. In a circle, we have how many radian? I am also feeling very proud. Ministry of Railways. I was teaching to Ministry of Railways. It also feels good. Okay. Fine. In a circle, how many radians? Thank you, Satyami. 360 degrees, 2 pi radians. Okay, why? In a circle we have 2 pi radian, we know this. In a circle we have 360 degrees, we know this. In a circle we have 360 degrees, we know this. But let me explain why. In order to know why, you must know the basic definition of a radian. A radian is a measure of plane angle. A radian is a measure of plane angle. A radian is a measure of plane angle. Yeah. A radian is a measure of plane angle with its vertex at the center of circle of radius r, subtended by an arc whose length is equal to r. This is defined as plane angle, 1 radian. This is defined as 1 radian. I repeat it here. Radian is a measure of plane angle with its vertex at the center of a circle of radius r, subtended by an arc of length r. So arc or lengths subtend plane angles, and the measure of plane angle is given in radian. You can do this small experiment at home. You'll have a lot of fun if you do this. You can do this, just take a paper and draw a circle and you can do this experiment. Now what you do is, you take a paper and draw this circle, draw the arc of the same length, then take one more. Then take one more. One more radian. Take one more. Take one more R. 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 You will find that there are 6 full radians and still 28% is left out here. 28% is left out. So in circle we have 6.28 radians. 6.28 is approximated to 2 pi. From this we got the concept 2 pi radian is 360 degrees. Clear? Radian concept, everyone clear? Now steradian. Steradian is a measure of solid angle with its vertex, center of a sphere, with its vertex at the center of a sphere, of radius r, with its vertex at the center of sphere of radius r, subtended by an area, subtended by an area, subtended by an area equal to area of a square of each side r. What is the area of a square of each side r? R square. So this is R square area. Area of a square of each side r. R square. This R square area is subtending one steradian. This is one steradian. This is one steradian. Okay. So in sphere, how many steradians you have? Let us see. If you take a circle, what is the circumference of the circle? Circumference of a circle of radius r, 2 pi r. Each r is subtending 1 radian. Therefore, in a circle we have 2 pi radian. Similarly, if you take a sphere of radius r, area of the sphere is 4 pi r square. Each area r square is subtending 1 steradian. Therefore, in a sphere we have 4 pi steradian. That is the beam area or beam solid angle. Yes. So, an isotropic antenna is one which has radiation pattern of a sphere. Sphere has 4 pi steradian. So, directivity is 4 pi by omega A, 4 pi by 4 pi. That's the reason why it is 1. And indirectly, the definition of directivity is number of antennas required to cover a sphere. Therefore, also it is 1. Rahul. Yes, correct, Rahul. Correct. Is it clear? So good, so good, too good. Nice. I hope it is clear. Okay. Shall I show you animation for this? Do you like to see the animation? If you want, I can show you animation for this. Shall I? Radian concept. Yeah, I'll show you. I'll show you the animation. You can see. Easy. Now it will be easy. Radian concept. Circle of radius r with its vertex at the center of the circle of radius r subtended by an arc of length r. More clarity if you want. You can see this. More clarity. The circle of radius r subtended by an arc of length r which give you 1 radian. Steradian is a measure of solid angle. Each r square is subtending 1 steradian. The sphere of radius r, 4 pi r square area. Every r square area is subtending 1 steradian. Projection also you can see. This is a projection, very clear. This will give you 1 steradian. Calculation part is also there. Circumference by radius, 2 pi radian. Area by r square, 4 pi steradian. Radian is a measure of plane angle. Steradian is a measure of solid angle. That's the reason why radian into radian, plane angle into plane angle. Radian square, which is steradian, solid angle. Radian is given in terms of degrees. 1 radian is 57.3 degrees. Therefore, degrees into degrees, square degrees is also one more unit for beam area. Yes. Is that clear? What can we do? Some more animation? Okay. You can go for animation. I'll just verify. I must have some animation for this. Yeah. This for radian. See, I took with radius r, I drawn a circle. With the same r, I drawn an arc. That arc is subtending 1 radian. Two radian, 3 radian, 3.14 or pi radian. Next half, pi more. Total 2 pi radian. Steradian also you can see. Total sphere 4 pi steradian. Remove this one part, 3 pi steradian. Remove this part, hemisphere 2 pi steradian. Remove this part, pi steradian, 0 steradian. So anyways, where we got diverted. An antenna has a beam area of 2 pi steradian. Directivity of antenna is 2. Yes, just let me know. Is that clear? I'm just trying to on the AC. If you feel there is disturbance or noise, please let me know. Okay, is that clear? Any disturbance? I just turned on my AC. Any disturbance because of that? It's very hot here. Rahul, Satyami. Amit, Lokesh, everyone, is that clear? I'm not able to receive messages. Just please let me know. Is that clear? Everyone, is that clear? I guess I am not able to receive messages. I'll continue. Sometimes there will be lag in messages, okay? An antenna has a gain of 20. An antenna has a gain of 20. Then gain in decibel is. An antenna has a gain of 20. Then gain in decibel is. Anyone, can you answer? Without calci, you should answer this. An antenna has a gain of 20, then gain in decibel is. Without calci, you need to answer. Fast. Everyone answer fast. Without calci, you all are present. I am not able to receive the messages. No update. Without calci, you need to solve this. An antenna has a gain of 20. Calculate gain in decibel. It is 10 log 20 to base 10. But for suppose you don't have a calci, and how to solve this? Very simple. If the gain is 10, gain in decibel 10 log 10 to base 10, 10 decibel. Gain is 20, gain in decibel 10 log 20 to base 10. When the gain has got multiplied by 2, you will have 3 dB improvement. Without calculation, you can say it is 13 dB. For every 3 dB, the gain gets doubled. For every 3 dB, the gain gets doubled. Therefore, directly you can tell the answer as 13 dB. Is it clear? Next question. An antenna has power gain of 30 and directive gain of 50. Efficiency factor is eta GP by GD 3 by 5 0.6. Option C is the answer. Option C is the answer. Is it clear? Next question. An antenna has a total input power of 10 watt, in which 2 watt is lost power and 8 watt is radiated power. The efficiency factor is 0.3, 0.5, 0.6 and 0.8. What is given is an antenna has a total input power of 10 watt, in which 2 watt is lost power, eight watt is radiated power. Efficiency factor is dash. Try to solve this. Everyone, Satyami, Rahul. Solve this, dear. What's the answer? For an antenna, total input power is 10 watt, of which radiated power is 8 watt, lost power is 2 watt. Is asking find efficiency factor. Efficiency factor is radiated power by total input power. Radiated power is 8 watt by total input power is radiated power plus lost power. 8 by 10. 0.8. Efficiency factor is 0.8. In terms of percentage, it is 80%. In terms of percentage, it is 80%. Next question. A half-wave dipole has a radiation resistance of 73 ohm and loss resistance of 27 ohm. Percentage efficiency is, try to solve here. A half wave dipole has a radiation resistance of 73 ohm and a loss resistance of 27 ohm. Find percentage efficiency. Efficiency is defined as the ratio of power gain to directive gain is defined as the radiated power to total input power, can be defined as radiated power by radiated power plus lost power, total input power. Radiated power is I square RR, where RR is radiation resistance, by I square RR plus I square RL. Efficiency is RR by RR plus RL. Percentile efficiency is RR by RR plus RL into 100. Calculate 73 by 73 plus 27 into 100. Percentage efficiency is 73%. Percentile efficiency is 73%. Remember, he is asking percentage efficiency, thereby 73%, not 0.73. Not 0.73. That is what I am trying to tell you. Percentage is asking 73. Only eta, efficiency factor is asking, then 0.73. Percentage efficiency is asking, right, in terms of percentage, 73%. If you are writing 0.73, you are saying 0.73 percentage, means less than 1%. Got it, Satyami? If he is saying efficiency factor, then 0.73. Efficiency factor, eta, 0.73. Percentage efficiency, 73%. This is how I make mistakes. Wantedly I gave that question. Wantedly I had given these options also in that way. Can you please confirm, is there any noise due to air conditioner? Please let me know once. Is the voice clarity, everything is clear, or is there any disturbance because of the air conditioner? Okay. Thank you. Next question. An antenna has a beam efficiency of 60%. Then stray factor is dash percentage. An antenna has a beam efficiency of 60%, and stray factor is dash percentage. How are beam efficiency and stray factor related? How are beam efficiency and stray factor related? Beam efficiency and stray factor, how they are related? Beam efficiency and stray factor are complement to each other. If beam efficiency is 60%, then stray factor will be 40%. Beam efficiency is 70%, stray factor is 30%, and so on. So what is the answer? Beam efficiency is given as 60%, stray factor will be 40%. Option B is the answer. Question number 5, option B is the answer. Next question. In a communication system, if effective aperture areas of transmitting and receiving antennas are doubled and the distance reduced to half, the capacity of the system increases by a factor of 4, increases by a factor of 8, increases by a factor of 16, remains unchanged. That is how you make mistakes. You are thinking that this is the previous year question paper. This is from the previous year question paper, am I right? No. I changed the question. Read the question properly. I changed the question. Hey, just kidding. No problem. We will do so much practice, Satyami, that you will not do mistake. Don't worry. How is your job going on? Now read the question carefully and answer. Read the question carefully and answer. In a communication system, if effective aperture areas of transmitting and receiving antennas are doubled and distance is reduced to half, the capacity of the system is given by according to Friis transmission equation, WR by WT is equal to AET AER by R square lambda square. This is Friis transmission equation for any wireless communication system. Having transmitted power WT, effective aperture area of transmitter AET, distance between them R, effective aperture area of receiver AER, frequency F, wavelength lambda, Received power WR. Read again. Read again. Satyami. Read again and let me know now. Because I have given you equation for this case. I have given you equation. Now you tell me. Very good. Effective aperture area of transmitter doubled. Effective aperture area of receiver doubled. R got half. Lambda unchanged. 2 into 2, 4. This is R square by 4 will move up. 4 into 4, 16 times. AET AER by R square lambda square. It increases by a factor of 16. Option C is the answer. No problem, no problem, no problem. Clear? Next question. In a given system, the noise figure is given as 2. Effective noise temperature TE is dash degree Kelvin. Do it, dear. What's the answer? Tomorrow morning, Satyami, tomorrow morning we'll have MCQ on antennas marathon starting from 6 a.m. Probably it will move from 6 to 11. So we'll cover so many MCQs related to antennas. So what's the answer here? Just let me know what's the answer. That's correct. Wonderful, wonderful, wonderful. What is noise figure? F is equal to 1 plus T by T naught. But T naught is absolute temperature. 290 degree Kelvin. Your noise figure is 2. Is 1 plus T by T naught. T by T naught is 1. Effective noise temperature is equal to absolute temperature. 290 degree Kelvin. Absolutely correct. Wonderful answering. Option B is the answer. Option B is the answer. Wonderful. Super. Very good answering. How about your job, dear? You are doing in Infosys, I think. TCS or Infosys? That's a good one. Next question. Which of these is Gauss law for electric fields? Which of these is Gauss law for electric fields? Gauss law states that the amount of flux cut through any closed surface is equal to charge enclosed by the surface. This is called Gauss law in true form. This is called Gauss law in true form. Substituting electric flux density defined as electric flux per unit surface area. Electric flux is given in coulomb. Area given in meter square. Consider small surface area ds. Flux associated with it is d psi e. That is d psi e by ds. From this d psi e is equal to d into ds. Scalar notation. Vector notation. D psi e is equal to d dot ds. Plus psi e is equal to closed surface integral of d dot ds. This is a relation between flux and flux density. If you go for the RHS, charge enclosed. If rho L is the line charge density, it is defined as charge per unit length. For suppose if you consider a line of length L, carrying a charge Q, then this line is supposed to have uniform line charge density rho L, which is given by Q by L, total charge by total length, coulomb per meter. In this length, if you consider a small length dl, the charge associated with this is dq, then rho L is dq by dl. From this dq is rho L dl. Q is line integral of rho L dl. Equating, but we are considering the law, therefore you should take the generalized form. Let me do it for surface now. If you do it for surface, if you do it for a surface, then for a surface, surface area S, total charge Q. The surface is supposed to have surface charge density rho S. Total charge by total surface area. If you consider a small surface area ds in it, the charge associated with it is dq, unit coulomb per meter square. If you consider small surface area ds, charge is dq. From this dq is equal to rho s ds. Or q is surface integral of rho s ds. Similarly, when you consider a volume V carrying volume charge density rho V, if this carries a charge Q, then this volume is supposed to carry volume charge density rho V, which is total charge by total volume given in coulomb per meter cube. In this, if you consider small volume dV, charge associated with it is dq. Rho V is equal to dq by dV. dq is rho V dV. Q is volume integral of rho V dV. As we are considering the generalized case, we will consider volume, equating both sides. For this true form, we get surface integral of d dot ds is equal to volume integral of rho v dv. What do you get? Surface integral of d dot ds is equal to volume integral of rho v dv. This is called integral form of Maxwell's first equation. Vipro. What is A for apple? What is this A for apple? Option number. I'm just revising EMFT concept for you. Okay. Okay, that is A for apple. But I'm trying to revise the concept for you people. Okay. Is that clear? It's called integral form of Maxwell's first equation. If you apply divergence theorem, what is divergence theorem? Closed surface integral of A dot ds is equal to volume integral of del dot A dv. It's called divergence theorem. Closed surface integral of A dot ds is equal to volume integral of del dot A dv. What is the significance? Divergence theorem. If you consider a closed surface, and on this closed surface, if you try to keep a energy source called A, let the energy source A is the light source. It can be any source, okay? If you try to keep a energy source A, let A is any energy source. If you try to keep it on this closed surface, the amount of light that you kept on this surface will be equal to the amount of light that is spread in this volume V. The spreading of this light is given by divergence. Therefore, this is called divergence theorem. This is the physical significance of divergence theorem. Is it clear? Amit, transmission lines is the most easiest part. That's the easiest part of EMFT. Next week we'll start. March first week. Transmission lines, because by that time I'll complete wave propagation. Meanwhile, you go through wave propagation, okay? Stay tuned, Amit. We are going to derive all the Maxwell equations in this session also. So just stay tuned, it will be a revision for you. Okay? This is divergence theorem. Applying divergence theorem on LHS, closed surface integral of d dot ds is equal to volume integral of del dot d dv is equal to volume integral of rho v dv. Removing the volume integral on both sides, del dot d is equal to rho v. This is called differential form or point form of Maxwell first equation. So thereby revision is also done. Answer was very simple, but just I want to revise Maxwell equations. So question number 8, A for apple. Is that clear? Next, Amit. Scary boy, once again. Derivation is very simple, don't worry. Early morning classes will change the time. Tell me what time is convenient. Shall I repeat? Deva, I'll explain, I told you. We'll start. This is different series, MCQ series, Deva. We'll start that also. Okay, anyways. Optical fiber communication, separate series we are starting. What is the name, scary boy? I'll take. As a promise, I'll take, okay? Give me some time, I'll take, okay? Because we are going with some motto. I'll take that also. You mean how much is the best score for GATE exam? Score 90, you'll get AR1. Small change. The both are same, no? 1 second. Small change. Let me make it dot. Del dot E is 0. This one. Yes, now you tell me the answer. Okay, don't worry. That's not vector. Okay, fine. Anyways, okay, I'll add this vector. Okay. Okay. Which of these represent conservative property of electric field? Which of these represent conservative property of electric field? We know work done is equal to force into displacement. Work done is a scalar quantity. Force and displacement are vector quantities. Dot product of two vectors is scalar. Therefore, W is F dot L, where F is electric force. It is Q into E. Electric force means force acting on this charged particle in the presence of electric field E. Substituting work done, W is equal to QE dot L. No. This means this W is nothing but the work done in moving this charge Q in the presence of electric field E by value of L is called work done. If you consider a small work done dW, that means moving the charge by value of dl. From this W is Q into integral of E dot dl. If you take an assumption that an external agent is doing the work, W is minus Q into integral of E dot dl. We know electric potential is work done per unit charge is minus integral of E dot dl. V is equal to minus integral of E dot dl. V is minus integral of E dot dl. This is when I took a path L. The vector field E is crossing the length this is the length dl. If this path L has a limit A and B, and at origin you have the charge Q because of which electric field is moving, then A is at a position vector RA and B is at a position vector RB. Q is at origin. Then the potential difference between A and B, VAB is equal to VA minus VB, that is moving from B to A, is minus integral B to A E dot dl. This is for the potential difference formula. That's for VAB. We know E is equal to Q by 4 pi epsilon naught R square AR. DL is equal to DR AR. E dot dl is Q by 4 pi epsilon naught R square of dr. Substituting VAB, VA minus VB minus integral Q by 4 pi epsilon naught R square of dr. Now A and B are changed by the R values, therefore it is RB to RA. This implies VAB is equal to VA minus VB. That's equal to minus Q by 4 pi epsilon naught R square integral of 1 by R square minus 1 by R minus of minus plus 1 by R RB to RA. VAB is equal to VA minus VB. This is equal to Q by 4 pi epsilon naught 1 by RA minus 1 by RB. VAB is equal to VA minus VB. Q by 4 pi epsilon naught RA minus Q by 4 pi epsilon naught RB. Comparing, you get that VA is Q by 4 pi epsilon naught RA, potential at point A, potential at point B, Q by 4 pi epsilon naught RB, potential at any point is Q by 4 pi epsilon naught R. Okay. Let me answer, Satyami. Let me answer. So that's potential formula. If you consider 2 points now, A and B, potential difference between these 2 points, VAB, VA minus VB. If you extend this up to C, VAC, VA minus VC, extend this up to D, VAD, VA minus VD. You join this. VA minus VA, 0. When you join the value, when you join the loop, at a given point, there cannot be potential difference. Therefore, V is equal to minus integral of E dot dl. But when you close the loop, this value will become 0. Therefore, closed loop integral of E dot dl is equal to 0. Integral form of Maxwell's second equation. If you apply Stokes' theorem on this, closed loop integral of E dot dl is equal to 0. If you apply Stokes' theorem on this, according to Stokes' theorem, closed loop integral of A dot dl is equal to surface integral of del cross A dot ds. Stokes' theorem says that if you take a closed loop and if you place a source on it, let it be some light source A, the amount of this energy or light source that you are kept on this loop will be equal to the orientation of this light in this surface surrounded by the loop. The more number of light you keep, the more amount of light will be orienting in this particular area. That's the significance of Stokes' theorem. If you apply Stokes on this, closed loop integral of E dot dl is surface integral of del cross E dot ds is 0, implies del cross E is equal to 0. Differential form or point form of Maxwell's second equation, del cross E is equal to 0. That means curl of E is 0. Orientation of E is 0. That means E is irrotational vector. That means E is irrotational vector. Yes, static electric field is irrotational. It cannot be rotated. They move in straight line. This is called conservative property of electric field. Now you tell me the answer. Now you tell me the answer. Yes, dear. Now you tell me the answer. Why? Why? You can see here now, closed loop integral of E dot dl is 0. Here dot ds is there, dot dl is 0. One more, del cross E is equal to 0. This one, 1 and 2. Option A is the answer. Yes, Satyami. Correct. Deva. Is it clear, Deva? Okay. Are your concepts getting revised or not? Every now and then we must refresh EMFT, otherwise it will be gone. Every now and then we must refresh EMFT. EMFT will be permanently stored after rigorous amount of practice. Until that it is volatile. Next question. Which of these represent Ampere's law in static fields? Which of these represents Ampere's law in static fields? Yes, dear. Which of these represent Ampere's law in static fields? Ampere's law. According to Ampere's law, the line integral of tangential component of magnetic field intensity around a closed loop is equal to the current enclosed by the loop. In simple, you can say closed loop integral of H dot dl is called circulation. Circulation of H is equal to current enclosed. This is called Ampere's law in true form. If you write current in terms of current density is defined as current per unit surface area, unit ampere per meter square. If you consider a small surface area ds, the current associated with it is di. Scalar notation, dA is equal to J into ds. Vector notation, it is J dot ds. I is equal to surface integral of J dot ds. Relation between current and current density. Substituting here, closed loop integral of H dot dl is equal to surface integral of J dot ds. This is called integral form of Maxwell's third equation. Integral form of Maxwell's third equation. Applying Stokes theorem on this, closed loop integral of h dot dl is equal to surface integral of del cross h dot ds is surface integral of j dot ds implies del cross h is equal to j. This is called differential form or point form of Maxwell's third equation. Option B, modify. What happened to option B? I'll modify, wait. Yes, 1, 2, 3, 2, 3, 4, 1, 3, 4, all. Let me know the answer. Let me know the answer, dear. Satyami, what's the answer? What's the answer, dear? What is the answer? See carefully, Satyami. See carefully and tell me the answer. It is not B, it is not B. See carefully. Carefully you see all the options. See all the options and tell me the answer, dear. Why this is wrong? Closed loop integral of h dot dl is equal to I enclosed. Closed loop integral of h dot dl. There is vector, dear. Don't worry, typing. That's all typo, that's it. Closed loop integral of h dot dl is equal to I enclosed. Same one. Closed loop integral of h dot dl is equal to surface integral of j dot ds. Same one. Del cross h is equal to j. B is equal to mu naught H. H is B by mu naught. For this one also. 1, 2, 3, 4. Option D is the answer. Why? H is B by mu naught, no? H is B by mu naught, no, Satyami. Del cross H is equal to J. H is B by mu naught. Del cross B by mu naught is equal to J. This one. All the options are true. Am I correct? Let me know. Am I correct? Next. Which of these represent Gauss law for magnetostatics? Gauss law for magnetostatics is from the concept of non-existence of magnetic monopole. A magnetic monopole cannot exist. That means if you take a permanent magnet and divide this permanent magnet into two, subsequently it forms north poles and south poles. A single pole cannot exist. And magnetic flux lines will move from north pole to south pole. Uniform magnetic field will be moving north pole to south pole. Uniform magnetic field from north pole to south pole. It will be uniform magnetic field from north pole to south pole. So outside the magnet, the magnetic flux lines will move from north pole to south pole. Inside the magnet, they move from south pole to north pole, forming the closed loops. Therefore, always magnetic flux lines always form closed loops. And magnetic flux density is magnetic flux per unit surface area, Weber per meter square, or the great Nikola Tesla. From this magnetic flux density is d psi m by ds, implies d psi m is b into ds, scalar notation. Vector notation, d psi m is b dot ds. From this psi m, surface integral of b dot ds is a relation between magnetic flux and flux density. But if you consider a permanent magnet from north pole to south pole, the uniform magnetic flux of psi m. So what is the net flux generated by this magnet? the relation between magnetic flux and flux density. Just wait, Satyami. Relax. Volatile. EMFT volatile. No problem. Sometimes I do forget. You people forgetting is not a big thing. I do forget concept. Good. I want to know, Satyami, how much is Siam? How much is Siam? How much is Siam? In that equation, what is the value of Siam? If you consider a permanent magnet, you will have North Pole and South Pole. The magnetic flux lines will move from North Pole to South Pole outside the magnet. They move from South Pole to North Pole inside the magnet. So what is the value of Siam there? What is the net flux generated by the permanent magnet? What is the net flux generated by the permanent magnet? 0. Because the amount of flux that it is giving out from North Pole to South Pole is Siam. The same amount of flux it is consuming from South Pole. The amount of flux that it is giving from North Pole, the same amount of flux it is consuming from South Pole. So the net flux generated is 0. Thereby, closed surface integral of B dot ds is 0. Integral form of Maxwell's fourth equation. If you apply divergence theorem, closed surface integral of divergence theorem, closed surface integral of A dot ds is equal to volume integral of del dot A dV. Applying divergence, closed surface integral of B dot ds is equal to volume integral of del dot B dV is equal to 0, implies del dot B is equal to 0. This is called differential form or point form of Maxwell's fourth equation. So the equations are closed surface integral of B dot ds is 0, del dot B is equal to 0, 2 and 3. Option B is the answer. Correct, Satyami. Correct, Deva. So this will complete all the 4 Maxwell equations, am I right? If you had observed carefully, what we have done is, for each question I explained one Maxwell equation. The concept was actually to cover Maxwell equations, not these questions. So we had completed Maxwell equations for static fields. Let me note down. Equation number integral form, differential form, source. Maxwell first equation, integral form, closed surface integral of d dot ds is equal to volume integral of rho v dv. Differential form del dot d is equal to rho v. Source, Gauss law for electric fields. Maxwell's second equation. Closed loop integral of E dot dl is 0. Plus del cross E is equal to 0. Source, conservative property of electric field. Third equation, closed loop integral of h dot dl is equal to surface integral of j dot ds. Differential form, del cross h is equal to j. Source, Ampere's law. Fourth one, closed surface integral of b dot ds is equal to 0. Del dot b is equal to 0. Divergence of magnetic flux density is 0. Therefore, I can say B is divergence-less field or B is solenoidal field. Source, non-existence of magnetic monopole or Gauss law for magnetic fields. Here, del cross E is equal to 0. Implies E is irrotational vector. E is irrotational vector. Or you can write E is conservative. That is summary. With the red ink, write the law. Sorry, Satyam, I had not seen. And just now I am reading your comment. I had not seen. Sorry. So what to do now? Shall I write it again? Actually, I can't see what you are typing. Only I will shift the tab and I see. So while writing, okay. Next question. Which of these are resultant of Faraday's law? Which of these are resultant of Faraday's law? According to Faraday's law, the induced EMF within any closed path is equal to the rate of change of flux linkage d lambda by dt, with lambda is the flux linkage given by n psi m. Therefore, from the definition of Faraday's law, VEMF is equal to n times of d psi m by dt. Later on, scientist named Heinrich Friedrich Emil Lenz said that the induced EMF will always oppose the flux produced it. Therefore, he had introduced the negative sign there, the minus sign. If you consider a straight conductor, number of turns n is 1, VEMF is equal to minus d psi m by dt. VEMF, V is equal to closed loop integral of E dot dl. And now psi m is equal to surface integral of B dot ds, implies closed loop integral of E dot dl is equal to minus d by dt of surface integral of B dot ds, implies closed loop integral of E dot dl is equal to surface integral of minus dou b by dou t dot ds. This is called integral form of Maxwell's second equation for time varying fields. Remember dear, in these equations, equation number 1 and equation number 4 won't change. They are same for both static fields and time varying fields. Only 2 and 3 will vary. 2 will vary because static electric field is conservative or irrotational. If time varying electric field is also irrotational or conservative, it cannot be part of an EM wave if it is moving on a straight line. Therefore, static electric field is conservative but not time varying electric field. Static electric field is conservative but not time varying electric field. That's why del cross E is 0 only for static fields. It must be not equal to 0 for time varying fields. So for time varying fields, you should get a value not equal to 0. This is integral form of Maxwell second equation for time varying fields. Now applying Stokes theorem on LHS, closed loop integral of E dot dl is equal to surface integral of del cross E dot ds is equal to surface integral of minus dou b by dou t dot ds, implies del cross E is equal to minus dou b by dou t. As I told you, only static electric field must be conservative but not time varying electric field. Del cross E is equal to 0 is only valid for static electric fields. If for time varying electric fields, del cross E must be not equal to 0. Because if del cross E is 0, E is irrotational. And if time varying electric field is irrotational, it can't be a part of a wave. Therefore, del cross E is 0 is only valid for static fields. It is not varying for, it is not valid for time varying fields. This is called differential form. Differential form or point form of Maxwell's second equation for time varying fields. For time varying fields. Clear? Therefore, del cross E is equal to minus dou B by dou T. Option B is the answer. And also it is very clear here, if you see static fields, static electric field and static magnetic field are independent of each other in static fields. Whereas in time varying fields, orientation of electric field, del cross E, orientation of electric field depends on time varying magnetic field. There is interdependency. Wherever there is a wave, there will be interdependency. Orientation of electric field depends on time varying magnetic field. There will be interdependency between electric field and magnetic field in time varying fields. Correct. Is that clear? Next one. Which of these are resultant of inconsistency of Ampere's law? Which of these are resultant of inconsistency of Ampere's law? Ampere's law is del cross H is equal to J. This is Ampere's law. But Maxwell said that this particular equation is valid only for static fields. It will not work for time varying fields. What he had done is, he took divergence on both sides. Then what you got is divergence of curl of any vector. According to vector identity, this must be 0. So if it satisfies vector identity, del dot J must be equal to 0. But if del dot J is equal to 0, it is not satisfying continuity equation. What is continuity equation? Continuity equation is from conservative property of charge. Can anyone tell me what is conservative property of charge? According to conservative property of charge, the rate of decrease minus the rate of decrease of charge within any closed volume is equal to net outgoing current. It's a very simple phenomenon here. If you are having your cell phone and you are using continuously, the rate of decrease of charge in that cell phone is equal to the amount of current that is coming out of that particular phone into the motherboard. If you use more current is consumed, charge will go down rapidly. It's a natural phenomena. Rate of decrease of charge within a closed volume is equal to net outgoing current. This is called conservative property of charge. We know Q in is volume integral of rho v dv. And we know I out is surface integral of j dot ds. Already both these equations I had explained in this particular class. Minus d by dt of Q in volume integral of rho v dv is closed surface integral of j dot ds. Implies closed surface integral of j dot ds is volume integral of minus dou rho v by dou t of dv. Applying divergence theorem, closed surface integral of j dot ds is volume integral of del dot j dv. Applying divergence theorem, closed surface integral of j dot ds is volume integral of del dot j dv is equal to volume integral of minus dou rho v by dou t of dv. Removing volume integral on both sides, from continuity equation, del dot j is equal to minus dou rho v by dou t. This is called continuity equation. But here in Ampere's law, once I apply vector identity, we are getting del dot j is equal to 0. But according to continuity equation, del dot j must be equal to minus dou rho v by dou t. And continuity equation cannot be wrong because it is from a natural property called conservative property of charge. This is what Maxwell has claimed. Maxwell has claimed that this cannot be wrong. That means there is some mistake here. What he said is, Ampere is not considering displacement current which can flow in air. That's the reason why this equation is failing. What he had done is he modified the equation. He said that Ampere is inconsistent. That's why we got the name inconsistency of Ampere's law. Maxwell said that Ampere is inconsistent. Thereby the name inconsistency of Ampere's law. Maxwell contribution. What he said is, this Maxwell equation is not considering displacement current which can flow in air given by JD. It is only considering conduction current, because according to Ampere, current can only flow when there is a conductor. Now applying divergence on both sides, del dot del cross H is equal to del dot of J plus JD. It must satisfy vector identity. Therefore, this is 0. Del dot J plus del dot JD is equal to 0. Implies del dot JD is equal to minus del dot J. It must satisfy vector identity as well as continuity equation also. If it is satisfying continuity equation, del dot JD is equal to minus of del dot J is minus dou rho v by dou t. If it is satisfying continuity equation, implies del dot JD is equal to minus of minus plus dou rho v by dou t. We know from Gauss law, del dot t is equal to rho v. Substituting del dot JD is equal to dou by dou t of del dot d. Implies del dot JD is equal to del dot dou d by dou t. Implies JD, displacement current density, is equal to dou d by dou t. Therefore, the modified equation is now del cross H is equal to J plus JD, where J is conduction current density given by sigma E, JD is displacement current density given by dou d by dou t. Now if you observe these two equations, carefully, from Faraday's law, we got del cross E is equal to minus dou B by dou T. And from Maxwell contribution we got del cross H is equal to J plus JD, sigma E plus dou D by dou T. If you compare these two equations very carefully, what we understand is spatial orientation. Del cross E means curl of E. Spatial orientation of electric field depends on time varying magnetic field. Spatial orientation of magnetic field depends on time varying electric field. There is an interdependency between time and space. There is an interdependency between electric field and magnetic field, which is a must and should condition for a wave to exist. Is that clear? Is that clear? So if you see this equation, which of these is the resultant which of these are resultant of inconsistency of Ampere's law? Del cross H is equal to J plus JD, sigma E plus dou D by dou T. Option D is the answer. Clear? Next, if an antenna is radiating circularly polarized wave, the polarization of antenna is, an antenna is radiating circularly polarized wave. An antenna is radiating circularly polarized wave. The polarization of the antenna is, polarization of the antenna. Antenna will not have separate polarization. Polarization of the wave will become polarization of the antenna. If antenna is able to generate or radiate circularly polarized wave, then antenna is also circularly polarized. Antenna do not possess its own polarization. Polarization of antenna depends on the polarization of the wave it is radiating. No, Satyami. The concept is antenna will not have any polarization on its own. Antenna will not have any polarization on its own. If it is able to generate circularly polarized wave, then the antenna is said to be circularly polarized antenna. If the antenna is able to generate vertically polarized waves, then the antenna is said to be vertical antenna. If the antenna is able to generate horizontally polarized wave, it is said to be horizontal antenna. If the antenna is able to generate elliptically polarized waves, then the antenna is called as elliptical antenna or elliptically polarized antenna. Antenna do not possess any polarization in itself. Polarization of antenna is nothing but polarization of the wave it is radiating. Okay? That's a property of an antenna. That's why I gave this question. If a transmitting antenna has an output impedance of 50 ohm and the same antenna is used for receiving purpose, then its input impedance is then its input impedance is what's the answer here? Then its input impedance is yes dear, please let me know what's the input impedance. This is again a property of antenna. If you are using an antenna as a transmitting antenna or receiving antenna, its impedance will not change. If it is a transmitting antenna, it is called as output impedance. If it is receiving antenna, it is called as input impedance. But the impedance value won't change. Property of duality. Property of duality in antennas. An antenna which is used as transmitting antenna can also be used as receiving antenna. Clear? From here we'll deal in the next class, okay? Because that is altogether a new concept, we can deal in the next class, no problem. Unacademy has two paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access, rank improvement batches, and crash courses. In Iconic, you'll have all these features of a Plus subscription. Along with that, you have a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts, preparatory study material, personalized test analysis, study booster sessions of workshops, and a customized study planner. Because we know that a study planner given for a student does not work for another, because each one of us will live in a different life. So we need customized study planner that will be provided by your personal coach. There will be dedicated doubt clearing educators to clear your doubts within 1 hour, and your personal coach will do your SWOT analysis and work on your weakness and try to improvise your weakness. And in Plus subscription, remember dear, unlike other online platforms, we don't charge anything extra for rank improvement batches and crash courses. They're all free. They all include into the Plus only. And Iconic include all these features and also have some additional features. If you are going for Plus subscription or an Iconic subscription, I recommend you to go for a no-cost EMI. No-cost EMI is one where total cost will be divided by number of months without any extra charge. Very much student-friendly, will be useful for you. And also you can use our team code. Remember, it is not the individual code. We use team code KNR10 to avail extra 10% off. The speciality of team code is not only that you get extra 10% off, but also you'll get complete team support. The complete team of Gate Conqueror will support you. With Iconic subscription, you have a personal coach and you get 1:1 live mentoring, improving your chance of getting a top rank. And if you are talented here, you can write combat this Sunday, that is today. You can write the combat. Combat is a live quiz competition conducted separately for mechanical, civil, electrical, EC and CSIT, where we will be asking you 20 questions, 60 minutes will be given, and it is today at 11 a.m. because we are crossed 12. And all the participants will get 20% guaranteed scholarship, and 500 lucky participants will also win a chance or stand a chance to win all these prizes. And we are ready to give away 4 crore as scholarship, and toppers will get 100% scholarship also or free subscription. And the good news is you need not pay anything for this. The enrollment is completely free. You can use our code KNR10. And if you are having any doubt in your preparation strategy, you can contact our counselor. And this is the number where you can contact the counselor for your preparation journey, subscriptions and latest offers. Unacademy has recently introduced a feature called Ask a Doubt, through which you can ask unlimited number of doubts. You can ask 3 doubts at a go and you can get the solution in your preferred language. It is also very easy to ask a doubt here. Click, crop and submit. A super combo offer going on. With every 2-year subscription, we are giving away 1-year subscription free for campus placement and IT jobs. With every 1-year subscription, we are giving away 6 months subscription for campus placement and IT jobs. The rank predictor is on here. Just log in, go to Gate landing page, then click on rank predictor banner. There is a link for the same. Select your stream, select your session appeared, paste your URL, your rank will be displayed. These are the special class features here where you have interactive live classes for the learners, polls for the learners, raise a hand option. You never miss a class when the notification is on. You can download the lecture notes then and there and you can access anytime and anywhere. We introduce community here through which you never miss any update from your favorite educator. And also you can download notes and practice material, and also you can share your feedback directly via polls with your favorite educator. As you know, every week we start 7 to 8 new batches. These are the new batches which are started on 16th of February. Resilience Gate 2023, Resilience batch for Gate 2023, Electrical Explained Bilingual. Resilience Gate 2023 for ECE Explained Bilingual. Ascent Gate 2024, ECE Explained Bilingual. Ascent for Gate 2024 for Electrical Explained Bilingual. Evolve Gate 2023 for Electrical Explained Bilingual. Evolve Gate 2023 for ECE Explained Bilingual. These are the new batches. You can join in any one of them. You can use our team code KNR10. Remember our team code. Special feature, no other code has this special feature that we not only give you 10% extra off, but also it gives you complete team support. Thank you all dear. Thank you all for joining. Let us meet tomorrow 6 a.m. morning session MCQ 3. Thank you all and good night. Good night, good night. Deva. Good night, Deva. Good night, Satami. Thanks for joining.